Hello everyone, today we're talking about the cardiopulmonary system. So to begin with, small, simple animals have something called a gastrovascular cavity that allows for the exchange of materials outside and into the cell through the fusion. But since the fusion is slow through long distances, more complex animals have a circulatory system which allows for fluid to be transferred from cells to the organs that then do exchange outside with the environment. So some animals have opened circulatory systems, while vertebrates have closed circulatory systems that allow that work through blood and through pumps and vessels. Thank you.
The human cardiopulmonary system is a complex interaction of several components, including the heart, vasculature, blood within that vasculature, and the lungs. The human heart is composed of 4 chambers with 2 atria at the top and 2 ventricles at the bottom, and is divided into a low pressure pump on the right and a high pressure pump on the left. Oxygen-poor blood returns to the heart through the vena cava and enters the right atrium. From the right atrium, it moves to the right ventricle, and then through the pulmonary arteries goes to the lungs. Gas exchange occurs in the lungs, and then the oxygen-rich blood returns to the heart through the pulmonary veins to the left atrium. From the left atrium, it moves to the left ventricle, where it is then forcefully ejected through the aorta to the rest of the body.
As mentioned before, blood goes through the cardiopulmonary system, and the heart is what keeps it going. But this raises the question, what keeps the heart going? The heart, just like every other part of the body, is dependent on nerve impulses to continue the muscle contractions. However, the heart is unique in that it has a specific thing called the SA node, which allows it to fire autorhythmically. The SA node starts a signal which disperses through the atria, and then it hits the AV node, which creates a small delay. After the small delay, it goes to the bundle branches, which takes the signal all the way to the apex of the heart. The apex of the heart is where the Purkinje fibers are, and the Purkinje fibers create a muscle contraction in the ventricles of the heart, which pumps the blood out. We can see this entire process on electrocardiogram as represented here. As you can see, this first initial section, including the hump, is the SA node. The flat section is the AV node where there's a delay. The small drop is the bundle branches, and the major spike is the Purkinje fibers firing.
Deoxygenated blood flows from the heart to the lungs. The lungs are organs of the respiratory system, and they function in gas exchange. For air to come into the lungs, the diaphragm contracts, increasing the air volume in the lungs and decreasing the air pressure. This pulls air into the lungs. For the air to reach the lungs, it must first go through the nasal cavity, where it is filtered, humidified, and warmed. It then goes to the pharynx, larynx, and then trachea. The trachea goes down and branches off into 2 bronchi, one going to each lung. The bronchi then branch off into smaller sections called secondary and tertiary bronchi. The smallest bronchi are called bronchioles, and at the end of these bronchioles you'll find alveoli, which are small air sacs. Alveoli have a surface area that's 50 times greater than our skin, and they are the site of gas exchange. They are also surrounded by capillaries. For air to leave the lungs, they go out the same way that they came in. The diaphragm relaxes. This decreases the volume of the lungs and increases the air pressure in the lungs, pushing air out of the lungs.
Gas exchange across respiratory surfaces takes place by diffusion. Gas exchange occurs in the alveoli. Oxygen is diffused from the epithelium of the alveoli into the capillaries, and carbon dioxide is diffused from the capillaries into the alveolar airspace. Blood has a low partial pressure of oxygen and a high partial pressure of carbon dioxide when compared to the alveoli airspace. Alveoli helps cause the diffusion of oxygen into the capillaries and the diffusion of carbon dioxide into the alveoli airspace. Tissue capillaries have partial pressure gradients of oxygen that favor diffusion of oxygen into the interstitial fluid and also favor the diffusion of carbon dioxide into the blood. Carbon dioxide from respiring cells is put into blood cells and then transported by the plasma in the forms of hemoglobin and sodium bicarbonate ions.
So, blood is our fluid that transports ions throughout the body and performs diffusion with all of our different organs. Red blood cells contain molecules called hemoglobin, which each contain 4 iron atoms. These iron atoms bond with oxygen, causing them to go from a 3+ state to a 2+ state. Now, each of those bonds is with an O2 molecule, meaning that each hemoglobin can carry up to 8 oxygens at a time. Due to the large amount of hemoglobin in each red blood cell and the millions of red blood cells in our blood, we are capable of transporting an immense amount of oxygen at a time. Because of this, even a small drop in blood pressure can lead to a large deficiency in oxygen transport.
Arteries are the blood vessels that flow away from the heart, whereas veins are the blood vessels that flow towards the heart. Capillaries are the small intermediate blood vessels that connect the arteries to the veins. Vasoconstriction and vasodilation can regulate blood pressure and affect temperature. Vasoconstriction tightens the blood vessels, whereas vasodilation widens them. Vasoconstriction can result in a decrease in heat loss by decreasing the blood flow in the skin. Vasodilation can result in an increase in heat loss by increasing the blood flow in the skin.
The 2 most common conditions related to the system are a heart attack and a stroke. So a heart attack is the death of cardiac muscle tissue from blockage of a few coronary arteries. Coronary arteries basically supply O2-rich blood into the heart muscle. A stroke is the death of nervous tissue in the brain, which is the aftermath of rupture or blockage of arteries in the head.
So thank you guys for watching our presentation.